Okay, and this is what you sent in. I would like to make an amp loud enough to play the Continental Club's volume. Now, Continental Club is a club in Austin where Stevie Ray used to play. It's right there on South Congress, and it's a very popular venue. And good bands play there. Do you play there, Diego?
Every now and then.
Oh, that's a cool venue, man.
Yes, and it sounds great.
And
Really woody and comfortable.
matter of fact, that club is famous. And when we designed our version of a Strat back in 1994, we named it the Continental. We named it after that club. Okay, so it says I'm interested in a single channel 40 to 50 watt Fender style amp with a Model 100 reverb built inside of the chassis, but not as an add-on unit. I have questions about these circuits. Now, on these two circuits here, you're saying, could you discuss mods for the bass channel on both? Now, if you're just going to build a one-channel amp, why are you interested in modding the bass channel? Or
I just squeezed in an extra question that I had, just out of curiosity.
I'll tell you, if I was gonna play us the 6G 6B Bassman, I would use the bass channel. I think the bass channel in this sounds better than the other channel, and also the bass channel has 3 stages of gain, so you can modify that bass channel a little bit, and it'll be much more touch sensitive and responsive than the normal channel. This is a better. Matter of fact, this circuit right here is real similar to a train wreck circuit. It's actually an improvement, I think, over the train wreck circuit because it's got this cathode follower driving the tone stack. Now, you would want to change these tone stack capacitor values. I'd probably leave that one at 250, but these other two here, you'd probably want to change these to well, you could go with blackface values or you could go with tweed values. You know, tweed values are 2.02s. And then the blackface value would be a 0.1 and a 0.047.
And how about the slope resistor?
More bottom end on the blackface ones.
And would you leave the slope 1 meg?
No,
or 50,
no. You could use 56K, 100K. Either one of those would work well. And I would leave all this other. You could leave all this other stuff the way it is. And then, but there's some other mods you'd want to do on this to make it more guitar friendly. Like for instance, you may want to make a smaller one here to give it a little bit more edge and more upper end bite. You may want to get rid of this here. This is taking high end off. And no, wait a minute. That's part of the tone stack. I thought they had one on the plate resistor. Do we have any plate resistors here with that on there?
Yeah, the next stage.
Right here. It's right here. This is where it is. I'm sorry. I knew it had one, and I was looking at it funny. Now I'd get rid of that. That's taking your high end off right there. And you might want to change this capacitor value here to make it more guitar friendly. Maybe cut that in half, do a 500 picofarad there. And but that, very, very few changes need to be made. Just you change your slope resistor and a couple of tone caps, get rid of this cap here, and maybe cut this one in half, and that should do it. Maybe make this one a little smaller. You could do a 10 or a 5 or something kind of small there to where it's going to give it some bite for your guitar. But I don't know, this other channel here, this is just a stock Fender channel. It's not, it's just going to be a blackface stock sound. But see, this isn't going to have the gain. Your other one here, you got 3 stages of gain. You got this stage here, 1, 2, 3. Now you can't count your cathode follower because you're actually losing a tiny bit there. But that's a great little circuit there. Anybody got any experience with this circuit? They want to make a comment on it Raise your hand if you do. I've seen touring acts before where they've used this amp and they plug into the bass channel and just play it stock with no mods. It's a great sound. Okay, no comments on that. Go ahead, Diego.
So where would I inject the reverb
Well,
on
now
this channel?
that depends on what kind of reverb you want. Now, you know what you could do? There's a couple of things you could do. One of them is you could take a signal off of this cathode here, this cathode follower, this 100K, and have that go to your reverb circuit, and then have the return just be your normal channel. Just plug it into your normal channel here, and then this could be the return. Then all you would need is a driver tube, and this would give you tone controls here on your reverb return. Or you could put a single. You could use a single tone stack. Maybe use a compound roll-off tone stack, where if you turn it one way, it adds high end. You turn it the other way, it takes off high end. Change it to that type of tone stack here, and then this volume control would be like your reverb control, and then just mix it right on in. That's my suggestion.
Because my idea is to build from scratch and just have one channel. So if I'm going with the bass channel, I won't have the normal channel.
No, it would still be just one channel. You wouldn't have these jacks right here. You wouldn't have it be dadgummit, I can't get this thing to do right. There it is. You wouldn't need those jacks. I mean, that would be your RCA reverb return jack in the back of the amp.
Right. Oh, okay.
See, it would still be a one-channel amp. And this would be the channel, but then you'd take a signal off of this, and this would need to go to some kind of power tube or a 12AT7 that's ganged together. You need to get about 3 or 4 watts somehow,
right.
Which you could do it. Let's see, how many tubes?
My idea is to use your Model 100 reverb with the special transformer, the 1 to 100.
Yeah. 110 to 1 or 112 to 1.
Yes.
Yeah.
So instead of connecting the plates and the cathodes and the grids together to get 5 watts, I'm just using half of the just one triode with a 2.7 cathode resistor. So my question was, if I'm going to inject a reverb send from the cathode follower, do I need a coupling cap going to the 500 picofarad to the mixing pot?
Well, with the 500 picofarad is the coupling cap.
That's the coupling cap. So I don't need an extra coupling.
Let me pull up my schematic for my Model 100. So
because
I know
when I injected that reverb into my JTM 45 design, we needed an extra coupling cap, and we used a 0.02, connecting it to the cathode follower to the 500 picofarad.
Oh, okay. Yeah, you do need a coupling cap because, see, this 3 meg right here, this 3.3 meg is a direct path. There's nothing to block DC on this. So yeah, you'd need a coupling cap here, and you're going to use my this circuit.
Yeah, that thing sounds great. Sounds better than anything else.
Yeah, well, we've gotten a lot of good feedback on this over the years. I mean, every amp that we've ever sent in for review that we use this reverb circuit, they said it was the best reverb they've ever heard. And,
yeah, it is.
It's a great, and we worked on it for 2 years. I mean, it's not a copy of somebody else's reverb. This was done trial and error, listening test and changing stuff, and just we played with this thing for a long time, and we had a couple of different versions of it, and this is like the finalized version. And so this is going to take 2 tubes. This will take
Mhm.
2 tubes. Yeah, you would need a coupling cap here.
Is
And you
that when
can,
you use a regular? Does that one use a regular 4AB3? Just a regular Fender tank?
yeah, use a regular Fender tank, but it doesn't use a regular Fender transformer because see,
Ah.
we're driving it with a 12AX7,
Mm-hmm.
and this 12AX7 you need a much higher turns ratio transformer. We're using I think that we're using 112 to 1 transformer here, whereas the Fender uses like a 54 to 1 or 56 to 1, something like that. So, and that way we can get it, and you can get enough signal, even though it's a 12AX7, you can get enough signal to drive a pan, especially those Belton pans. Those Belton pans just seem to be a little bit more efficient. And, there's some little tricks that we do along the way. This is like a little negative feedback circuit here, this 500 picofarad here. And this is like a little tone stack here. And let's see, what else have we got? Here's some more negative feedback here. And there's your reverb control, which is basically a volume pot. And then we're taking some highs off here, but we're using a big cap for the output. And
And then from the output, do I need another 0.02 coupling cap to the merging resistor?
well, you're using a 0.1.
Right, but to connect that 0.1 to the
No, you don't need another one.
reverb.
The reason you got the coupling cap here is to block DC. See, because there's DC on this plate, and you don't want to
Right.
run DC as the output. You just want AC. So we've already got a coupling cap here, and then anything on the other side of that coupling cap is AC right there. So you don't need another coupling cap.
Right. So that one goes straight into the merging resistor.
Yeah, I can go. That could go right here. If you were just using the bass channel here,
Mm-hmm.
you could put the merging. Use this 470K as a merger resistor, and the 0.1 would connect there. And then your input, the input here will go off this cathode follower, and I would use a 0.02. You could use a 0.02. It doesn't matter what you use, because
Mm-hmm.
the only thing that's doing is blocking DC from going down this 3.3 meg. The 500 picofarad is going to filter out bottom end from hitting that tank. So it doesn't matter if you use a 0.1, 0.047, 0.02. You can use anything, and it's not going to make any difference really.
What kind of voltage are you running on this thing?
Oh, now wait a minute. You know what? On this one, you don't need this. You don't need that. That's to mix the dry signal with the wet signal. You don't need that.
When I brought my JTM 45 to you, we did it both ways, and the way that sounded the best was this way with the 3.3 meg and the 10 picofarad. The other way didn't have enough reverb, and it took a lot of tone out of the amp.
Yeah, but this is not, you don't have any reverb at all going through this. This is your dry signal here. See, that's your dry signal. I think if you're going to use this as a separate unit and come back in on the merger resistor, you can cut all this off right here. You can take this. This can be eliminated. That whole wire right there can be eliminated. You don't need it, because all that's doing is mixing dry signal back in. You don't need dry signal mixed back in. You already got the dry signal coming through this circuit here. Let me get my pointer so you'll be able to see it good. See your dry
Of course, you could put it in series with that whole circuit too, and use it as is.
I wouldn't do that, because this has got 3 stages of gain.
Right.
And you're gonna compound the noise if you do that. I would run it in parallel with this. And by the way, we made 2 versions of this Model 100. We made the serial version, which is this, and then we also made a parallel version, which was the same thing, but without this. Now, I think what you did here at Amp Camp is we tried bypassing this last stage here. That's what we did. And it sounded better if we didn't bypass the last stage because you wouldn't get enough reverb. But I'm not suggesting doing that. I suggest leave the output stage here. Everything's exactly like it is. The only thing is you don't have this dry signal trying to mix back in, because you don't need the dry signal since you've got it already here. See? Yeah, I remember very distinctly. That's what we did, is we tried to take it from here without using that last stage, and you didn't have enough reverb. So I would say leave that stage in, because that'll give you enough reverb. And see, you've got...
What is the B plus on this? You show B plus, but doesn't have a value on it.
We'd hook that up to the screen supply, whatever the screen is. If it's 450, 470, 460, whatever. It's not critical, just as long as it's around 400 to 480, anywhere along in there, it'll work fine. Yeah.
Let me ask you, for the reverb driver, the cathode resistor, the 2.2K.
This here?
Yeah. Yes. Should I ground that one with the screens and put the screens all the way down with the mains, or should I do it the blackface way? Put the mains on the preamp, and the screens on the preamp and the driver on the preamp too.
Okay. Well, now see that depends on your layout. Now, see, Fender had these cathodes for the driver tube grounded at the back of the amp near the reverb RCA jacks. And because of that, they had a parasitic issue, and they had to take their screen supply and ground it with the preamp to stop it. I wouldn't do it that way. I would take this and ground it back where the screen supply is, and I would have the screen supply grounded at the same place that the main filter's grounded and the center tap of your power transformer. That's the way I would do it. I think that'd be the best way to do it. Now this one here should be grounded near that filter cap. See, because this filter cap is feeding this tube. So I would ground this and this together.
And should they go to the preamp or with the screens and the mains?
Well, it depends on where you got this 22 at 500 grounded at. Wherever you ground this, that's where this one should be grounded. They should be grounded.
What would be the best? What would be the best way to do it?
Well, let's see. See, and then you've got this one here too. This one should be grounded here. And this, all of those should be grounded similar spot. This should all be grounded together. Well, no, not that one. I'm sorry. This one. Yeah, and this one. Those should all be grounded about in the same spot all together with that, because that filter cap is feeding all of those. See, think of it like this. This tube here is in parallel with this filter cap. Let's draw it another way. Show you what I'm talking about. If I can get my screen up here. Dadgummit, I had that a minute ago. Where is it? Here it is. Right here. Okay, the way these things are done is, think of it like this. Okay, so let's say you got a filter cap. Here's your filter cap. And it's grounded. Okay, and that's going to B plus somewhere. And this is feeding a tube. Well, the tube that's feeding is feeding a plate resistor, right? And that plate resistor is going to a plate. And then there's a cathode that the current's coming up through. And then there's a cap that's going to go to some sort of load to ground. Okay, well, when you can look at it like this. This filter cap is in parallel with this, and it's also in parallel with this, because you've got current that's coming up from ground. I'm going to go a different color. You got current coming up from ground going here, and it's going this way. And at that point, any AC would be bypassed to ground here by this filter cap, but that's competing with, excuse me, that's competing with this cap and this load going to ground. So this is in parallel. This cap and this plate resistor are in parallel with this cap and this load resistance. And this filter cap is in parallel with this whole mess here. So you want to ground these together. And the reason you want them to ground them together, you don't want any interference in here, because if you get some kind of interference in here, some kind of AC signal in that resistance from a previous stage, then you run the risk of having some sort of oscillation issues or some parasitic coupling. But if you have these connected at the same point, then there's no way anything can get in there. Make sense?
Yeah.
I probably could have drawn that better. Let's redraw it. Okay, think of it like this. Here, you got from the plate, think of it this way. You got a plate resistor and a filter cap, and then you also got a coupling cap and a load resistance. So now you can see this is in parallel with this. And then over here, you've got a cathode resistor. And so all of them are in parallel with each other. And that's why they should be grounded together.
And that common grounding point should go to the preamp or with the screens and the mains?
That depends on how you have it laid out. Okay, let's say you got it laid out. Let's take another, oh heck, I did that wrong. Let's go back to where we were. Let me do a Control Z and get rid of some of this stuff. Well, that didn't do it. Well, that didn't do it. This is going to do it. Boom. Okay. Okay, so let's say you got it laid out. Let's say this is your chassis here. Whoop. Let's say you got a chassis like yay, okay? And let's say, you got some tubes in there somewhere. These are not necessarily exactly the same. I'm just freehanding this, but you get the idea. Okay, so you've got components feeding this tube. And so whatever's feeding that tube, maybe you have your grounds around that tube. And that's your preamp tube. And then this is the next preamp tube. And this is the next one. And then maybe you got your power tubes over here. And so you'd have in your power transformer. Oh, wrong one. Let's let this be the power transformer. Here. Okay, there's a power transformer. And you got let's say you got your power transformer center tap ground. Uh-oh. And then you got your, that's not, okay. Let's say that's your center tap ground there. I keep getting the box. I'm not getting the line anymore. Okay. This should be it here. Huh? I don't know why this isn't doing right. I'm trying to just draw a line. Okay, so let's say that that's your center tap ground. Okay, and then you got your cathode grounds from here to there. And you got your main filter ground. We're going to do your filters in green. Let's say. And then this is going to be a filter. I'm going to put the filters on the bottom and the tubes on the top. Okay, so that's that. Okay, now over here, let's say you got another filter, and that filter is grounded here. Well, you're going to take your cathode of this tube and ground it near that filter. And then wherever the output of that tube is, let's say it's a, I don't know, some kind of pot or a volume pot or something, you're going to ground that in the same spot, whatever the output is of that tube. And then on this tube over here, you take your cathode and, you know, if the filter cap, if you got a separate filter cap feeding it, you're going to ground it near there. And let's say you just have one filter cap that's doing a bunch of these. Well, you can ground them all on a brass plate on the front and just ground everything on that plate. And like on your reverb is happening after your first tube, right? So you got your first tube and then it's going to your reverb send. So, you know, you're going to have, let's see, is that, let me look at that schematic and look at it again. Okay.
So the send, we send it to the mains and everything else.
See, this one here is driving a transformer. I would ground this one over with your actual screen, because if you got a transformer here, that's different than it being RC coupled.
Right.
And I would take that one and run it back over here, but only that one. Only that.
Okay,
one. These here, you could have the filter cap on the board and have that grounded. You could even have the filter cap. Well, I wish I could draw this thing right. It seems like this thing's not doing right. You could put your filter cap even, let's say you put it here. Put your little filter cap there, and there's the ground point, let's say. And you could have your cathode resistor here, ground at the same spot. And you know, and then maybe run a wire there to the front of the board, get a chassis ground going. And then this would feed your plate resistor going to here. Something like that. Okay,
so just to recap everything, the 2.2K cathode resistor for the reverb driver goes with the mains and the screens, and everything else goes to the front of the amp.
Yeah, you could have everything go to the front.
Okay.
I would use a brass grounding bus though, because that way the brass grounding bus is not going to have hardly any resistance at all because it's big. It's got a lot of surface area, and that's a good way to do it. And all the amps I build, I always use a brass grounding bus on the front. I love that. I mean, I've had some bad experiences by not using it.
Isn't the whole point that you're trying to make, though, is that every ground needs to be separate from each other?
Well, yeah.
So they don't interfere with each other.
Yeah, you don't want anything to interfere with something else. And because if you do, that's where you end up with oscillations and parasitic coupling and other type of undesirable issues. And there isn't anything worse than building an amp and you spend months building it, Then you turn it on and the damn thing's an oscillator. That's disgusting. Charlie's got his hand up. Go ahead, Charlie.
Just a quick question. Why do you use brass instead of maybe copper or something?
You can use copper. In fact, Rickenbacker used copper.
Okay.
Copper's probably better than brass. Brass is made from copper.
Well, yeah.
But you
But
copper.
the only thing I could think of was that copper corrodes more easily than brass.
That could be why Fender used the brass. But either one will work really well. You could use silver if you wanted to.
Yeah.
No holes barred, man.
You can use gold if you want, you know.
Yeah, the gold would work well. Okay. Chad's got his hand up. Talk to me, Chad. His hand
Unmuted.
Chad.
Cost is the number one factor.
Yep.
Brass is way cheaper than copper.
Yep.
Yeah. Is that
Similar why you don't use silver.
same reason you don't use gold too?
Yeah.
Okay, well, that makes sense. I must have inadvertently muted you. No, you're self-muted. Okay. I saw your mute thing go off, and I didn't do it. Okay. All right, so let's take this one step at a time here. We had your... okay, we were talking about the mods for the bass channel. Do you inject the reverb send to the plate of VB with a 0.02 and the reverb return to one of the merger resistors? I would actually, if I was going to use that... if I was using the bass channel, I would use this cathode follower because that's a lower impedance source. And it's going to be about the same, almost exactly the same amount of gain as coming off of a 12AX7. Actually, this one's using a 220K plate resistor, so you're going to get a little bit more gain out of this tube than you would a normal 12AX7, but then when you run it through the cathode follower, you lose a little bit of that. So the gain coming off of the bottom of this is going to be real similar to the gain coming off of the plate of a tube that's using a 100K plate resistor. And it's better to have a lower impedance source. So yeah, that'd be the place to get it. Let's see what your next thing was. Do you ground the 2.2K reverb driver cathode with the screens main? Yeah, we talked about that. And you said, or the blackface style at the preamp and moving the screens to the preamp section. I wanted to say that is a remedial fix that Fender did. They designed the blackface style amps, and they grounded that transformer driven reverb driver transformer tube, the cathode of that. They grounded to the back of the amp, and they had issues with it. And the way they fixed it is they moved the screen supply ground to the preamp, which is a mistake in my opinion. That's a remedial fix. I would have just grounded the thing where it should have been grounded to begin with and just not grounded on the back of the amp. But anyway, let's see. Should I keep the rest of the Model 100 reverb grounds at the preamp apart from the 222 filter caps that should go with the mains? I want to say something about that. Those 22 microfarad filter caps, I normally don't use those type of caps. Those are etch plate caps. But when we built the Model 100, we needed the space. It was a little box to put on the wall of the amp, and we couldn't put a full-size cap in there. It was just too big. It would have made the unit too big and bulky. And since it was just a reverb circuit, it wasn't really drawing a lot of current. We were using 12AX7s. They weren't drawing how much current at all. We thought we could get away with using those etch plate caps for that. So that's why we used the 22 microfarad. If I was building this from scratch, I might just go ahead and use a 20 microfarad if you got the real estate for it.
Okay.
Do I ground the remaining mixer resistor with the phase inverter ground? Well, the mixing resistor doesn't have, you're not going to have a ground on it because you're talking about the merger resistors?
Yes.
Yeah, see, it's not going to be grounded because you should take one merger resistor, it's going to go to the output of the reverb, and the other merger resistor is going to go to the output of the preamp. So neither one of those are grounded, really.
Okay.
Yeah. Let's see what else. If the normal channel of an AA864 is basically an AB763 circuit without the reverb and vibrato, why don't we need an extra 47K resistor to ground in order to emulate the intensity pot to ground to keep the gain structure the same? Well, you could. I don't know why Fender didn't do it. Let's take a look at that. Here's your AA864. Well, let's look at the schematic. And you see this is very, very similar to an AB763. As a matter of fact, I don't see any difference. This just looks the exact same as an AB763. Oh, okay, I'll tell you why. Here's why. Because this is only 2 stages. The AB763 has a 3rd stage. It's a reverb mixer stage. So it's going to have more gain than this normal channel.
Got it.
You want me to pull that schematic up and show you, or do you remember?
No. That answers the question.
Yeah. The AB763 has got a 3rd stage, the reverb mixer stage, and this doesn't. So this would probably even have less gain than an AB763. Matter of fact, if I was going to build an amp for guitar, I wouldn't use this normal circuit. I would use the 3 gain stages. I tell you, I've built them both ways, and the 3 gain stages is a good way to go because it just makes it more touch sensitive. It's like you're, it's got more response. It's got a better feel to it. It has, when you're soft, it's soft, and you pick a little harder, and it really makes a difference, on your pick attack. So
Yeah, that's what I need. That's exactly what I need.
now, if you're going to use this circuit, it's the same kind of thing. Get rid of these things that take off high end. I'd get rid of that. This is a low pass filter. I'd get rid of that. Probably make this one smaller. That 0.1 could go down to a 0.02. I'd change these to guitar values, 250 picofarad and maybe a 0.1 and a 0.047 or 2.02s. The 2.02s are going to be clearer. They're not going to be muddy in the bottom end. You might want to try that. And then you could voice this however you liked. You could try the 25 or 25, or you could, try a smaller one, a 10 or a 5, something to give it a little bit more bite. I know Scott's been designing a lot of stuff, and I think he's been using, Scott, you've been using smaller bypass caps than Fender, right? Scott McMillan? Hey, Scott, you there? It shows you on here. Okay. I don't know. Maybe he went to go get a beer. No, I think Scott uses smaller ones. I kind of like smaller ones too,
I think he said he liked to use 10s.
Yeah, I like 10s. I like 10s, 5s, and some of my stuff I've used a 1. But the bigger it is, the more chances you've got of it being boomy. And I don't like the low strings to be boomy. I like the low strings to be clear, and I like the high strings to compress. And when you use a smaller one, it increases the gain on the high end strings, and it kind of suppresses that low end so you don't have that boominess. It keeps everything clear in the bottom. Just like when you take some of the bass off of a kick drum in a mix, it clears it up, keeps it from sounding 40. That's F-A-R-T-Y, not F-O-R-T.
40.
Mm-hmm. That's a technical term we use in amp design. 40. All right.
Where would you inject the reverb on this design?
On this one here, I think what I would do, I think I would take it off of this plate right here with a .02 right there. You see where I'm at? Let me get my pointer. I'll take it right there. And if I was going to do a one channel, I would just inject it back here on this merger resistor here.
Okay.
Of course, you wouldn't have any of this stuff over here.
Right.
Yeah. Yeah, and see this here, this filter cap, this should be grounded. All of these grounds here should be approximately in the same spot, because all of the stuff here is all in parallel with each other. So this filter cap here, you can have them here. And you know what I would do? I would even go so far as to put the filter cap right on the board, right near the input. You can have
Yeah. That's what I do. That's what I do to
Yeah.
keep not less wiring around everywhere.
Yeah, that's what we did on the on a lot of our designs. We had a really nice layout on the Solo 7 like that. Let me see if I can find that one. I'll show y'all how we did it. If I have the schematic handy. Here's one. No, that's the schematic. I need the layout. Let's see, where's the layout? Reverb, Solo 7. Okay, I think I've got it under kits, because we do offer that as a kit. Yeah, here it is right here. Well, here's the front end. This is the one half of the layout. But see, we put the filter caps right here. And on the back, we had two boards. We had one board here with all your passive components, your capacitors and resistors. And then we put our filter caps back here. And that way we can have them grounded where they need to be grounded. See, we're taking the ground, we run it right over here to this input jack on this one. And this one here is going right to the mains ground. See there? Because that's feeding the reverb. That's feeding this reverb here. Going right back to the mains ground. So, and then the other side, let's see where the other side is. Yeah, this is the other side. It doesn't have any filter caps on this side, so. But all the filter caps are on the board on this one. This is part of the filter cap here. This one here, see, it says two. What does it say? Two center tap ground. And this other one, two front panel ground. See, so that one.
I think it says chassis ground.
Chassis ground, yeah. Well, the chassis ground is the main ground here.
Right.
Yeah, that's where we got our filament ground, our B plus ground. We got this filter cap ground. The output tubes are grounded there also. Well, they're grounded there through a, it's going to have a cathode resistor somewhere. I'm looking for it. I don't see it. Well, let's see. Here's your tube here. That's the grid. Well, I can't tell from this drawing. I have to probably blow that up some. Let me see if I can blow it up so we can see what the hell we're doing here. Oh, too big. See, these are the plates of your phase inverter. No, these are the plates. Here's your grid resistors. You got your 1.5 Ks going there. What's it, 1K? That's some kind of power supply deal going to those other filter caps. I can't see where the cathode resistor is. I know there's a cathode resistor in here somewhere. I don't see it. Maybe this is it. Yeah, this is it right here. This 820 bypassed by 25, and that's another 820 bypassed by 25. See all that's going to your main chassis ground right here. And then there's a filter cap, 100 at 500. All of that stuff is going to your main chassis ground for your output stage. All right. So what else, Diego?
I just had one more question about the phase inverter.
Okay.
This one, the A64 is a classic black phase, with those values, the 470 and
22
whatever they use.
and 1 meg, yeah.
Yeah, and the other one is almost like a 59 Bassman, but the cathode is a 820 ohms instead of 470.
Let's see. Okay, yeah, this is 820, and then it's got a 6800 going to a 4700. And then the other one is using a 22K. Okay, and they're using a 470 on this. But see, this one's using 12AT7, and the other one is using a 12AX7. So that's what the difference is. And also the feedback loop is different. Are you going to use a presence control?
Yeah, I want to. That always saves me.
I would use this one. I would use this one because this is a really good sounding presence control here. It's not scratchy.
Right.
Are you gonna? What's your impedance output going to be?
I'm actually using one of your train wreck transformers.
16 ohm.
So I'm going to use the 16 ohm for the speaker and the 8 ohm for the feedback.
Yeah. Well, you're going to need to change this feedback resistor then.
For the 8 ohm too?
Yeah, because see, this one's a 4 ohm, and they're
that's a 4 ohm?
Yeah, they use 2 8 ohm speakers on a Bassman.
Right.
All of the Fender speakers were 8 ohm except the 8-inch, and they were 4 ohm. Everything else was, if you see a Fender amp that's got two speakers, it's 4 ohm because they used 8 ohm speakers.
Mm-hmm.
And they always wired them in parallel. And you're not going to see any Fender amps, any vintage ones wired in series. They never did that. They always did them in parallel. So,
it sounds zero. There's more gain in series, right?
What? No, there's not more gain in series. It's the same amount. It's the same amount of gain either way. The speakers don't produce gain anyway. The gain comes from the amp. But whether you've got all the current going through both speakers, which is series, and the voltage splitting, or with parallel, it's the other way where you've got all the voltage going to both speakers, but the current splits. But it's the same amount of power either way. It's just one way you're splitting the voltage and keeping the current the same, and the other way you're splitting the current and keeping the voltage the same.
Got it.
So if you're going to go, if you're going to hook the 8 ohm tap up for the feedback, you're going to need to cut this resistor. Let's see, what are you going to do? Double it. I'd probably use 100K. 100K resistor.
And for 16 ohm, how many? What would be the value?
For what?
For 16 ohm.
Probably 220K would be right.
220, okay.
180, 220. You could put a 250K pot in there and play around with it and find a value you like if you wanted to. And then just replace it with a resistor. But just guessing, see if this is a 4 ohm and this is 56K, if you're running at 8 ohm, you're going to double the voltage and half the current. So you would need to double this drop-in resistance in order to have the same amount of feedback over here. Because see, this doesn't matter as far as current. The only thing that the feedback matters is the voltage.
Okay.
And you're going to get about double voltage on 8 ohm than you would on 4. So therefore, this drop-in resistor needs to be about double what it is now, and a standard value would be 100K.
Mm-hmm.
I like Gerald's idea of putting a pot in there and listening to it.
Yeah, well, that's the whole idea. The amp is supposed to sound good, right? So
Right.
what better way to do it than to experiment until it sounds the best that it sounds, and play with it. You could put a 250K linear pot in there and just set it up as a rheostat and just play around with it until you find a spot you really like. And then when you get to that spot, just measure the pot, see what it was.
Or since you're not using the other channel, you're going to have some real estate. You could just make that a permanent thing.
Yeah, you could. I've used a 5K pot, like on a AB763, where they're using the 8. I think it's a 820 load resistor. Yeah, I use an 820 load resistor. And an 820 drop-in resistor, and then they use like a 47 ohm or 100 ohm load resistor. I've stuck a 5K pot in series with the 820 feedback, but hook it up as a rheostat, and that works really well on that AB763 for variable feedback control. Because if you turn it where the pot's shorted, then you're dead nut stock. And then as you turn the pot to increase the resistance, you're getting less and less feedback, which gives you a little bit more gain, and it makes it a little more raw sounding.
Much more raw sounding.
Yeah, and that's a good mod for a AB763 type circuit. For one like this, probably, I don't know, that 4700 is about 5 times what the other is. And let's see, what is this? Is this? No, I'm sorry. The other's 820. So this is like maybe 50. This is about 60 times bigger. So probably a 250K pot if you wanted to have a variable. Maybe use the 56K, leave it in there, and then put a 250K pot in series with it, and that way you could, have a variable feedback control.
All right.
If you wanted that. Okay. Anything else? Anybody got any comments, questions, suggestions? Chad, you're already unmuted, bud. Go ahead and talk to me.
I got a question about the transformers. We've been talking a lot about transformers, and I'm specifically interested in, let's say 50 years from now, we're trying, my grandchildren, or maybe not grandchildren, but are trying to figure out a Kendrick amp, and they're trying to find a replacement transformer. And I guess I'm looking at old amps from the 40s, but I have the cross-reference guide, but when I go through them, either I'm finding typos or the numbers are off. They're not, is that by design, or is that just the closest thing within 10%, or
what numbers are off?
You know what I'm talking about?
No,
like if
I don't know what you're talking about. What numbers would be off? The part number?
Well, I mean, it varies. I guess. No. Part numbers. So I've got like schematics, and I'm going by the replacement, and some of the amps will be off, like almost double. Like let's see, I'm looking at a power transformer, and one brand has the amps double what the the replacement is double what the normal one would be. Everything else seems to be the same.
Is that for
it's
power?
Just, I don't know.
Power or an output?
Power.
For power.
And then a lot of the output ones, they don't put any values in. Yeah, for power. Output's pretty much the same.
Well, let me tell you this.
Pretty much the same.
The current rating on a power transformer is important because if you don't, it's all based on how big the wire is. Bigger wire is like having a bigger hose. Bigger hose can carry more gallons. And current is like gallons. If electricity was water, current is gallons. So if you've got a transformer that's wound with small wire and you try to run a bunch of current through it, it's going to heat up. You're going to get a lot of voltage drop across the internal resistance of the wire, and it's also going to heat up, and it can eventually burn up because it's going to get hot. Just like you take a coil of wire and run a bunch of current through it, it's going to heat up. If you get thicker wire, the current rating will go up, and it'll also run a little cooler, and it's less likely to fail. And it also doesn't sag as much because, you know, when you hit a chord or hit a note, if you're playing harmonica, you hit a hard note on an amp, and then you're drawing a lot of current through that output stage. When that current goes through there and you get the ER drop across the internal resistance of the winding, your plate voltage goes down. So what happens? Plate voltage goes down, the output of the amp goes down a little bit. And then as the string dies down a little bit and it's not pulling as much current, then the ER drop isn't as much. Now your plate voltage goes back up and your gain increases. So that's how you get that compression and sag and singing quality and all that out of an output stage, is through that impedance. You don't want to have too much. If you have too much ER drop, you're going to overheat the transformer and you could burn it up, and you know, you could have other problems. And also if you get too much compression like that, it can compress off the front of the note, and if it compresses off the front of the note, then you don't have any note definition. And a fast enough player, you get a real fast player in there, he can probably outrun the amp, you know. So I like bigger wire. I like bigger wire because I like that front end sting. I like to be able to cut through a mix. When I hit a note, I want to hear it.
So what would be a general rule of thumb then? So it's, instead of using a cross-reference guide, would I just figure out what the current one is and then go slightly bigger?
You could.
That, I mean,
if you want that. It depends.
Exactly.
You figure, okay, figure this. Like an amp like this. This is a Bassman. This is probably, I don't know exactly what it is. It's probably a 250 milliamp, I'm guessing. It might be 220, it might be 260, but it's 2 something. It's in the mid 2s somewhere. Okay. And you could use something of that same value for another amp that used 2 6L6s and a few preamp tubes. You know, I mean, you could use a Pro transformer and a Super Reverb, for instance, or a Super Reverb transformer and a Bassman transformer, because those are all 2 output tube amps. So 250 milliamps would work fine for those. But if you really wanted to squeeze some performance out of it, jump it up to 500 milliamps or 450 milliamps. That's what we did on those Trainwreck Climaxes. We got a 450 milliamp transformer in a 2 output tube amp. So that thing's got lots more capability than what's needed. So when we slam a cord and the tubes are requesting current, that power transformer has no problem giving them any amount of current they want. And which, you know, and that has a certain feel to it. It's a sports car feel. It's like riding a Harley or something, you know. It's got performance behind it. If you took a deluxe transformer, say, which normally a deluxe is about 150 or 120 milliamp, I think a blackface deluxe 120 milliamps. You put that on a 2 6L6 amp, it's going to have a lot of sag to it. And it's also going to wash out. If you start banging a cowboy E chord and the drummer hits a cymbal, you're going to disappear because it's not going to be able to keep up. The plate voltage will go down. You start banging on it, and and that current flows through that B plus winding, and then all of a sudden your plate voltage goes away and your amp's all of a sudden not very loud. I'm sure most of you know what I'm talking about. So I don't know if
Had a guy had a Pro Junior years ago, and I guess the power transformer in it was so hot you could have cooked on it.
Oh yeah, and especially those ones that use a bridge rectifier, the full wave bridge rectifier, because that coil never has a chance to rest. At least on just a regular full wave rectifier, you're only using half of the coil at a time, so 60 times per second, each coil gets to rest just a little bit. But my drummer bought one of those new Marshall reissues that had the full wave bridge rectifier in it, and hell, within a year he blew the power transformer. Because it just wasn't wound with very big wire, and then the thing never got a chance to rest because it was a full wave bridge. Lee's got his hand up. Go ahead, Lee. Lee, jump in on us.
Hi, Gerald. Just might want to go do this next week. I just wonder why the power tube cathodes don't have resistors.
Because it's not cathode bias.
Okay.
There's two ways of biasing a tube. You can put a cathode resistor on it and bias it that way, or you can put a negative voltage on the grid. Either way, the grid is going to think it's negative by comparison to the cathode. And see, like for instance, on this one here, see, we're putting minus 58 volts on these tubes here.
Right.
You didn't have to. You could forget about this, ground these, and then put a resistor here on each one, and you could bias it that way, and you get a different sound because the bias would change a little bit. Even if you bypass these with a cap, the bias would change a little bit. It'd have more of a singing quality if you cathode biased it. It's punchier.
So
it's punchier if you fixed bias it. It's got more of a singing quality if you cathode bias it.
Right. So if it's not cathode biased, it's not grounded. I mean, it's not got a resistor.
It doesn't have a resistor, no. And matter of fact, that's how you can tell. If you look at an output stage, if the cathodes are grounded directly and there's no cathode resistor, it's got to be fixed bias.
Right. Okay.
Mm-hmm.
But then again, you can still, it's fixed bias, but you can put a pot in there and adjust it.
Yeah, this one here, you could change this 56K to a pot in series with a resistor, and you could adjust it.
Well, like on the trainer amp, same thing.
Yeah, the trainer amp's the same thing.
Yeah, it's the same thing. Thank you. That was it.
And you know what? Look at this. We were talking about that minus 36 not being enough bias voltage. Look at this. Of course, now this is using 5881s, which are the same as the 6L6. But look, they're using minus 58 volts on that sucker.